Good morning, everyone. We're really glad that we're presenting our final presentation face to face. It's more than a Zoom link, yani, so we're really grateful for this. To start with, let me introduce myself and my colleagues. This is Abdelrahman Rezk alongside Ashraf Ibrahim, Omar Kamaly, Nourhan Moussa, Shorouk Beshara, and Nourhan Moussa, and we'll be presenting today our final presentation for the smart mirror.
Interrupt 1 second. Just I want to make sure that everybody is wearing masks during the.
So before getting into the content of our presentation, I'm gonna go through our outline for this presentation. We'll be talking about motivation, then our product overview, product features, product pricing, system architecture, methodology, achievements and results, demo, and future work. So to start with, I'm gonna brief you what are smart mirrors in general. A smart mirror is basically a two-way mirror that has a screen in the back that makes the user see through the mirror and see the screen through it. So how smart mirrors initially started? So in 2003, this is the time where it started. It was called Mirror TV. So let me ask you a question. What do you guess? What's a Mirror TV in general, from your perspective? An answer? Exactly. This is how it started in 2003. Exactly. This was the first step towards smart mirrors, and since then, it started by the developmental aspect of smart mirrors into the commercialized aspect, and it was mainly focused on the entertainment aspect. As for our approach for the smart mirror, we will be tackling smart mirrors from a e-health aspect or healthcare aspect. So after the pandemic that we're living in nowadays, and after a few years of lockdown, many people nowadays prevent or avoid the crowded places such as hospitals or clinics, and they just go it when it's really crucial. So they always seek places that with least possible interactions with people. We decided to make a product that helped those people have quick checkups on their comfort of their home, using the smart mirror that will be able to run analysis about their body and their psychological health, as well as to detect some diseases. So the outcome of our presentation, or I mean the thesis project or the graduation project, is a commercialized product that will be targeting the healthcare segment and will be mainly focused on the customers who are influenced by smart homes, as well as gym, as well as hotels who are seeking a new level of using technology in their facilities and their rooms. Now, I'm going to leave you with Shorouk Beshara, who will be talking about the product overview.
Now, I'll talk about an overview about our smart mirror. We have a 32-inch glass that can operate as a reflective and a transparent dashboard at the same time. Otherwise, also we have an infrared interactive screen, touch frame to act as touch frame. We have an infrared active frame to act as a touch frame, so enables the users to touch the screen and navigate through it. All of these previously mentioned hardware components can be by 54.5 by 11.5 as width by height by designed with buttons such as switch on and off and volume up and down.
Please use a microphone عشان
our product features or why the customer will why we are different from another smart mirrors. So the first one is we detect and face and emotion detection. The user interact with the smart mirror and gets an information that corresponds to his emotion state that detected with our smart mirror. Second one is IR detection. We detect from IR some symptoms. So we take when it's appear a sodium ring or Arcus sensils on it. It's symptoms to high cholesterol level and high blood pressure. Also, we do some regular health checkups for the user, so he can or she can know his oxygen level and saturation. Also, the user can know his or her weight and height and circumference. Also, we have an entertainment Spotify. The user can play music on it. Also, the user can know the weather, and if the weather cold, he or she can it's appear on the screen of the mirror what clothes he or she should wear. Also, so this is why our product is different, and the features of product that tell us why we are different. And my colleagues also will explain in details these features. And also I'm going leaving you with Nourhan Moussa.
So like Abdelrahman said, the smart mirror idea has been there for a while. Actually, the smart mirror market is now estimated to be about $2.5 billion. And it will reach about $6.5 billion in 2031. Most of the fields that the mirror runs on, that is automotive systems, retail, and advertising, health, but they're still developing and working on it. And the last one is residential or consumer. So in order to do our pricing, we had to go through our competitors or the possible competitors that we could have. We started with the Poseidon Smart Mirror. That is, it's supposed to be for health and wellness, but the most thing that it does, that it reads the skin and scan its characteristics, and it's also it can be used for to provide like tutorials for kids on how to wash their teeth, videos, or run as a screen to run on Netflix and so on. The second one is the Toshiba Corporation mirror. It's more of a living mirror situation that it also works as a TV, and you can display it anywhere for tutorials or videos. And the last one, the last one is the Embrace Smart Mirror. It's motion activated, and it runs on Android. It runs a lot of apps from Twitter to TikTok to all the social media apps that are there. And it also runs with the voice gestures, and it sends emails and more for like social media. So most of the competitors that exist now had nothing to do with healthcare. But Smart Mirror, we're doing the two things, the entertainment part, as Nourhan said, that we have Spotify and other entertainment modules. And for the health monitoring, that we are doing the iris detection, the oxygen saturation and pulse, the physical one. And so for our pricing, the whole product costed about $775. And most mirrors actually are sold for about the starting price is from $250 to $1,050. So we wanted to go something in between, not something too expensive or too cheap. So we put about the profit would be about 20%. That gave us the price of $960, and that's our price for our mirror. And now I'll leave you with Omar for the system architecture.
For the system architecture, we have the Raspberry Pi. It does all the computations for our models and Python scripts. The Raspberry Pi is connected to the AUC camera and the sensors. After the computation is done on the Raspberry Pi, it's sent to the Magic Mirror framework, which is our graphical user interface. The Magic Mirror framework has the node helper, which is listening for any input from the Raspberry Pi. The configuration file for the Magic Mirror, it initializes the Magic Mirror with all the modules we did and all the user notifications we have. Also, as you can see in the figure on the left, we have modules, the weather, clock, news, and many other modules. These modules fetch the data from the internet using global APIs. For the integration part, we had many files, several models, machine learning models, several Python script. We had to integrate all of this thing together. For example, for the iris model, we had to use the face detection model first to detect the face. From the face, we had to detect the eyes from the face detection model and save it as an image. So we can then later run the iris detection model and send it the image we took from the face detection model. Another thing for the psychological part, the emotional state also, we had to use several models in parallel. We had to use also the face detection model so we can run it, and then the output we can send it to the emotional detection model. All of these things had to be integrated together. All of the output of these files were sent to the Magic Mirror framework to be output to the user on the screen. For the usage, to be able to run our smart mirror and use all of the features, we invented something called health check process before you can start the Magic Mirror. It's a step-by-step process which runs on the user before you can start the mirror. The process is user-friendly. The instructions of the process is done throughout speech and text. The process is divided to 3 steps. The first step is for the iris detection.
The second step is for the emotional detection, and the third step is for the physical check.
Okay, so as for the achievements and results, that basically recaps the product features with some technical depth. Our main aim was to provide or facilitate to the user regular checkups at their homes or at any convenient place. So to do so, we integrated 3 different modules which support the biological, psychological, and the physical feature. So for the biological, we are able to predict high blood pressure or high cholesterol level using already pre-trained model, which we have trained on our data set, which is the UpIris version 1. We achieved accuracy of 97%. We're also able to detect the pulse rate and the saturation of the oxygen in the blood using oximeter and to display the result to the user on the Magic Mirror framework. As for the psychological, basically we started, our main aim was to enhance the user's mood. So to do this, we display some affirmations. So first we started by collecting a data set of affirmations, and then we separated those affirmations according to 5 emotional states. And then we run the neural network, which actually detects the emotional state of the user, and then it displays the affirmation according to his or her current emotional state. We also facilitated breathing exercise, which allows the user to relieve stress, along with to be able to stream music through the Spotify application on our Magic Mirror framework, just to allow the user to calm down and relax. To mention that our neural network used has an accuracy of 70.2%, which is actually one of the highest accuracy when it comes to emotional detection. Finally, for the physical, we aim to calculate some of the crucial physical metrics for the user, which is the height, width, weight, circumference, body fat percentage. The result of any of those metrics actually achieved an accuracy of 90% or above. So to walk you through a little bit of technical depth, first we display the disparity depth map using 2 mono cameras, and then we also run in parallel Thunder Pose model, which is trained on the COCO key points dataset. They both work together in parallel to be able to measure those crucial physical metrics. So next, we would like to demonstrate to you our product, along with also showing you how we are able to use the product to do the full checkup.
Please wait, full checkup is in process. Follow up the instructions. Step 1: checking iris health condition. Please place your eyes near the camera. Step 2: checking emotional state.
And see, first we have captured the iris of the user just to detect.
Please place your full face near the camera.
Sodium ring in the eye, just which indicates high blood pressure or high cholesterol level. Then next we are detecting the current emotional state to output the affirmation according to current emotional state.
Step 3: checking physical state.
Finally, we are measuring the crucial physical feature.
Please stand 2.5 meters away from the camera and rotate when asked to.
Stand 2.5 meters away from the camera to detect the whole body from the lowest part to
Please
the
follow the physical instructions. Please rotate.
captured all the data required from the front image. Then it needs to capture some data from the back view.
Checkup done. Find your results on the second page.
Smart mirror is now ready for usage with all the indicators previewed on the smart mirror. The user is currently measuring his pulse rate and the oxygen saturation in his blood using the oximeter. Finally, we wanted to share some future work that we would like to adapt to our product. So what we have demonstrated is our final commercialized product. However, we wanted to take a further step and to take this project and to start a startup. So here are some points that we would like to do in the future. So we would like to enhance the graphical user interface by adding more features to the Alexa module. We also would like to preview some videos according to the user's in-body analysis to aid him in losing weight or getting in the perfect shape that he or she wants. Also for the biological, we would integrate the results of the oximeter along with the neural network to predict more diseases. And for the psychological, we would add LED lights in the frame that changes color according to the mood, just to enhance the user experience. And finally, also, we would like to add up some entertainment features such as Netflix or streaming through the internet. Thank you.